Hello everyone, this is Brad. I am currently a TA for Computer Science 340, and today I'm kind of creating a video to help introduce everyone to the Unix operating system by covering some basic Unix commands, and we're going to cover kind of what a Makefile is and how we're going to create one. So the point of this video is, again, to introduce you to those two things, show you how it's done, and just give you a very basic and easy to use kind of documentation. This is not meant to fully answer every single question. If you have any specific questions, I highly recommend reaching out to any TAs or your professor or your instructor, whoever's teaching, to ask any specific questions, and I'm just trying to give you a general introduction. So let's get started. Okay, so the first thing that we're going to do is we are going to SSH into the Turing server. So what you're going to do for this is you're going to open up the terminal. This is how Mac OS users are going to typically access it. In Windows, you can use PuTTY instead, which gives you a user interface. So I'm on my personal computer. What we're going to do is we're going to SSH. Then you're going to use your ZID. You're going to so you're going to use your ZID here. You're going to do an @ so it's pointing to which server, and you're going to want to choose which server you want. You can do Turing or Hopper as of me creating this video. Then you're going to identify a port. I apologize, my dog's right behind me. So this -P is a port flag, and we're going to choose port 22. We're going to do yes, so that way it will permanently add the turing.cs.niu.edu to a list of known hosts, and then we're going to enter a password. Awesome. Now we are in Turing, as you can see with the Z1923374 at Turing. So I am going to create a directory called example, so that way you guys can go ahead and use this for whatever you want to use it for, and I can just have, like I said before, a general introduction for you. So I'm going to do ls to show my current what my current directory holds, and now I'm going to do make dir example. I'll do ls, and we can see we have example right here. So I'm going to change directory cd into example. Now I'm going to ls, and as you see, there's nothing there because we are currently in the example. It was just created, and we didn't create anything inside of example yet. So now I'm going to make dir recitation. I plan on showing this during recitations, but again, this is meant as documentation that you can come back to. So now we're going to do ls, and we see that we have a recitation directory. So we're going to cd recitation. Now I'm going to do pwd for path to working directory, where we can see that the path that we're currently on is home Turing Z1923374, that's my current ZID, to example to recitation, which we can see here. I think this is called a relative path. Correct me if I'm wrong. I open any corrections at any time. Just go ahead and throw it down in the comment section, and I'll pin it. So now we're going to do make dir example 1. I'm going to ls. We can see we have example 1. So now we're going to enter there. And then we're going to use the copy command, which we're going to do cp at home/csci 340/assign 0/* dot. That means anything, then it ends in a dot. This is a regex expression that we are using currently in place here. Slash assign1 slash. So what happened here is that we forgot to give it a path. So we're going to use the up arrow, and we're going to give it the path of our current working directory. So I'm going to copy this, come here, right click, enter. So there is no such file or directory in here. But I'm going to still use this to show you what the copy command does. So what it does is it's going to take whatever is from here in the assign1 folder. So we're giving it the path to assign1. We're copying it into recitation. I'm going to try it one more time by just deleting this and see if it works. So there's no such file or directory, which means the documentation that they gave me is not currently up to date. Hopefully it will be up to date by the recitation and you guys can use this. But instead what we're going to do is I will create a Makefile. So I'm going to Vim. That's my preferred text editor whenever it comes to Unix. Makefile. I don't know if the M has to be capital or not, but I know if it is capital, it will still work. So now we have here a brand new Makefile. Now, there's a huge thing about Vim, and that no one knows how to use it correctly. Right now, we are in a weird mode. If you want to insert and type, you can't do it here. So what you need to do to actually type is you press I for insert. Now we're in insert mode, and we can type here. But I don't want to type anything yet. So I'm going to hit escape :WQ. This means write quit. Now if we hit ls, we see we have a Makefile. Okay, now that we have a Makefile created, we're going to actually go in and create this Makefile. So I'm going to open it back up with Vim, and I'm going to start actually creating it. So I'm going to go into an insert mode, so I press I. I'm going to create a comment. We're going to identify which program we're doing it for, which is lab training exercise. And then I'm going to identify the author. This is just a standard kind of approach to documenting your Makefile, so that way whenever you need to turn it in, it shows who created it and all of that, so that way we know who it belongs to and all of that. And this will be your name. Okay, so now we're going to actually create some variables for our Makefile. So our first and only variable that we're going to create for this is we are creating CXX flags. For this, we want to treat all warnings as errors, and we want to use the standard C++ 11 version. So this means we are using C++ 11 and treating all warnings as errors. And that's what this variable is doing. So now we're going to identify our program, which is going to be example. And we're creating this. So this right here is the executable. So whenever we want to run it, after we run make, we're going to do ./example. But to create this executable, we need an object file, which is example.o. So now we need to identify a compiler and any flags. So our compiler is going to be G++, and our flag is going to be what we just identified above. And we want it to be an object, and we want example and example.o as our dependencies. So now we need to actually create the flags for our object file. So we have example.o, which is going to take an example.cpp, where we need G++ as our compiler. We need to treat all warnings as errors and use C++11. So our flags -c because it's a C file, and example.cpp. So now we can compile, but an issue that we're going to run into is that executable and object files take up a lot of space. So we need a way to actually remove these. So we're going to set up a clean command. So we need to do rm-f for force. So we're running the remove command, and we are using the flag force anything that is an object file and the example executable. So this example right here, executable, is pointing to this, essentially. So this will remove what this creates. And this removes any object files. So let's say you had multiple object files that your example was relying on. This will still remove all of them. Okay, so that's going to be it for writing this Makefile. So we're going to do : write and quit. Enter. So now let's ls. Awesome, it's still there. Let's open it. Everything is saved, so we're good. Now, I don't want to write it when I quit this time. So now all I do is : q. And we're good. Nothing was saved. So if you go in and you make any changes or anything like that, you're like, I don't really like it, you can always do a : q to revert. Now, let's run this Makefile. So all we're going to do is make. And as you can see, there is no target of example.cpp, which is needed by example.o. So, because we can't create our example.o, it's going to stop there. So let's actually make an example.cpp. We're going to write and quit, ls, and it's there. So we're going to go back into example.cpp. For our C++ program, we're just going to do an extremely basic return. So we're going to include, #include IOStream. We're going to identify our main, and then we're going to return 0. So we're going to do standard cout, bit shift, and then 8 plus 4, standard end L. So what this should do is it should return 12. It should just print 12 to the screen. So let's go ahead and run our make. And as you can see, we can now use make. Let's ls. And now we have example.o. So we have our object file. and we have an executable example. So let's do ./example, and we have 12 printing to our standard output. Hey everyone, I was editing the video, putting everything together, and realized I forgot to show you how to actually clean and use your clean command that you created in the Makefile. So again, this is a very, very basic introduction where it should show you how to copy. It should show you how to change directories. It should show you how to find your path to your working directory. One other thing I will cover is moving to a parent directory is like this. If you want to access anything inside your current directory, you're going to do, for example, in a path, you do // which is why we did /example here. And then the copy did not work because it was not up at the time of recording this video. If you need a firm example of it actually working, reach out to your TA or try it yourself. I highly recommend, honestly, trying it yourself and play around with all of these commands. It will help you learn it if you actually play around with them. It will also help you learn if you ask questions. I mean, your TAs are getting paid to answer these questions, so you might as well use it. It's part of your tuition. And yeah, if there's anything else, please reach out. If there's any corrections you wanted to make to this video, put it in the comments. If it's correct, I will absolutely pin it and respond to you. So thank you for watching, and yeah, bye.